Hello friends, welcome to the module number 6 of our molecular symmetry. At last module we were discussing mirror plane. We have completed two mirror planes, vertical mirror plane and horizontal mirror plane, sigma V and sigma H. And I have told you that now we are going to see sigma D, which is called as the dihedral mirror plane. And in order to understand sigma D, the sigma V and sigma H should be very much clear to us. Sigma D is called as dihedral mirror plane, and the definition of sigma D is, it is such a plane that bisects two perpendicular C2 axes. What is the definition of vertical mirror plane? A plane that is parallel to the principal axis. What is the definition of horizontal mirror plane? A plane that is perpendicular to principal axis. Means sigma V and sigma D sigma V and sigma H we have decided with respect to the principal axis. But this third plane, that is sigma D, it has nothing to do with principal axis. Rather, it is decided with respect to the C2 axes that are perpendicular to each other. I am repeating what I said, ki sigma D has nothing to do with the principal axis. Rather, sigma D is decided with respect to the two C2 axes that are perpendicular to each other. So, what is the definition of dihedral mirror plane? It is such a plane which bisects two perpendicular C2 axes. The best example to explain sigma D is PTCl4. I have drawn two diagrams for PTCl4 molecule. Right now, you have to concentrate on the first image of PTCl4 molecule. Till now, we have seen principal axis in PTCl4, subsidiary axis in PTCl4, and vertical mirror plane in PTCl4, and finally horizontal mirror plane in PTCl4. There is one C4 principal axis in PTCl4 which passes through this platinum. There are four subsidiary C2 axes present in PTCl4. Likewise, there are four vertical mirror planes and there is one horizontal mirror plane in PTCl4. And now I am going to explain you the dihedral mirror plane that is present in PTCl4 molecule. As the PTCl4 is absolutely symmetrical, what definition I have told you for sigma D? It is such a plane that bisects two perpendicular C2 axes. Means, first of all, what we should have in the molecule, first of all we should have two C2 axes which are perpendicular to each other. So, and we have seen the C2 axis also in PTCl4 already. So, in this first diagram, I have drawn two such a C2 axes which are perpendicular to each other. We have seen this also as the C2 axis. Of course, this is the 1, 2, this is the third C2 axis, and this is fourth C2 axis. We have seen such four C2 axes in PTCl4 molecule. But right now, I have drawn only two C2 axes which are perpendicular to each other. Alright, this is the first C2 axis, this is second, and there is the angle of 90 degree. Which angle is becoming here? Right angle triangle. So, it is 90 degree, means perpendicular to each other. Now, according to the definition of dihedral plane, it is plane that bisects two perpendicular C2 axes. So, according to the definition, first requirement we have seen that there should be present two perpendicular C2 axes, and I have drawn it. Now according to the next part of definition ki a plane that bisects these two axes. So how will you pass the plane? So that you know na the meaning of bisect. Bisect means to cut equally. Alright, the meaning of bisecting means to cut equally in two parts. So we have from this two perpendicular C2 axes, we have to pass the plane which will cut these two perpendicular C2 axes, or we have to pass the plane in such a way that it will bisect these two perpendicular C2 axes. So in what way you can pass the plane? So that the plane will also be passed and it should be bisecting also. What do you mean by the plane? We have seen already or when we can say that the plane can be passed, if that plane can give two mirror images on either side of the plane, then we say that the plane will be passed. Now we have passed the plane like this already also. Now suppose I am passing the plane like this. Are you getting mirror image? This is the plane. Are you getting mirror image? Yes, of course, that we have seen already also. Simultaneously, is this plane cutting these two perpendicular C2 axes? Yes. These two perpendicular C2 axes are meeting at this point and this plane is cutting these two perpendicular C2 axes in this way. As this plane is bisecting two perpendicular C2 axes, therefore this plane is called as sigma D. Alright, do you get the meaning? As this plane which I have passed like this, as this plane is bisecting or cutting two perpendicular C2 axes, so this plane is called as sigma D. Secondly, in what way you can pass the plane, or better way, if this sigma D, let this sigma D be clear to you very well. If it is very well clear to you, then you can find the second sigma D also which is present here. Right now I am telling you the answer ki there is one more sigma D present in this plane, and if you have to find out the second one, then the first sigma D must be clear to you. In order to make it very much clear, I will be again using the model of PTCl4. This is the paper model for PTCl4 molecule, a square planar PTCl4 molecule. We have used earlier also. Platinum at the center and 4 chlorine atoms at the 4 corners of a square plane. As we have seen all the axes and all the planes already, I am again repeating or revising it. You can see by red line I have drawn the one C2 axis or one of the C2 axis. Again, this is the second C2 axis that I have drawn by using red line. At this, what is the angle between them? It is right angle triangle, so it is 90 degree. Means what? These two C2 axes are perpendicular to each other, and in between these two C2 axes I have passed this plane which I have shown by green color. As this plane is having mirror image on both the side, means we can say this is the plane that we can pass. But as this plane is cutting these two perpendicular C2 axes, hence this plane is called as sigma D. What it is called as? Sigma D, that is dihedral mirror plane. I hope now the definition or the nature of plane sigma D is very well clear to you. In simple way, sigma D is nothing but the plane that bisect two perpendicular C2 axis. That's it. Now my next question to you was, or I have already told you the answer for my question also, ki there is one more sigma D present in PTCl4 molecule, and in this molecule you have to tell me another sigma D apart from this. You can keep the same C2 axis perpendicular, and in another way also you can pass the plane. Just think over it. We have seen the planes already. With reference to that, you can find out the plane here. Yes, in what way we can pass the plane? Yes, as we have passed in this direction, similarly you can pass the plane in this direction also. If you are passing the plane like this also, then also you are getting the mirror image, and this plane is also a bisecting mirror plane that bisects these two perpendicular C2 axis. So this plane will also be called as sigma D. Alright, is it clear to you? Okay, so this is the one sigma D we have already seen, and my question to you was, find out the another sigma D present in PTCl4. How you will pass that another mirror plane sigma D? It will be like this, means in this direction. This is also called as sigma D. Alright, so these are the two perpendicular C2s, and these are the two dihedral planes. Now I have drawn another image also for PTCl4. Before, you must be remembering, we have find out 4 C2 axes in PTCl4 molecule. In what way we have passed that 4 C2 axes? One way was like this: 1, 2, 3 and 4. Among these 4 C2 axes, in the first image I have chosen only these 2 C2 axes which are perpendicular to each other. But you can choose the C2 axes which are passing like this also. This is the one C2. This is another C2. Now tell me, what is the angle between these two C2 axes? Perpendicular, they are 90 degree, or they are also perpendicular to each other. Here also the angle formed is 90 degree, means right angle triangle. So these two C2s are also perpendicular to each other. Now we have to pass the plane which bisect these two C2s. So easily you can imagine, or the very first what will comes to our mind, the plane will be passed like this, which is of course bisecting these two C2s, and which is dividing the image also in two equal halves. So here I will pass the plane like this, which is called as the sigma D. As in this image there were present 2 sigma Ds, of course now the molecule is same, so here also there will be present how many sigma Ds? 2. This is the first one, and which will be the another sigma D. Which is passing like this. This is also sigma D. Why? Because it is bisecting two perpendicular C2 axes. We are keeping the C2 axes same. We are not changing them. If you are passing the plane like this also, then also this plane is also cutting the C2 axis, or if you are passing the plane like this, then it is also cutting this perpendicular C2 axis. Hence, both the planes will be called as sigma D. Why I have drawn two images of PTCl4 molecule? Just to tell you that it is not necessary कि we should choose only this sigma D. It is not necessary that we should choose the sigma D like this also. But we can choose the planes sigma D which are present in this direction also. I'll show you the image on this paper model so that it will be totally clear to you. Okay, this was the first image. You can say that I have drawn on blackboard. In this first image, I have taken the C2 axis along this, the line which is passing in between the two chlorine atoms. That line, along that line I have taken two C2 axis, and the planes that are passing from platinum and chlorine atom, that I have considered plane. Okay, in first image I have drawn the lines for C2 axis that were passing from in between the two chlorine atoms, and I have chosen the plane which were passing from chlorine and platinum atoms according to first image. So these are our two perpendicular C2s, and these are the two bisecting dihedral mirror planes. According to second image, you can choose the line which is passing from two chlorine atoms and platinum as the C2 axis. Another line for C2 axis I have drawn which is passing from two chlorine atoms and platinum, and the plane I have drawn from the place in between the two chlorine atom. So anyway you can choose the C2 axis, and anyway you can choose the dihedral plane. It doesn't matter, or it will not go wrong. Again I am showing you, this is the first image. Alright, C2's dihedral planes, C2's and dihedral plane. Alright. Okay, so till now in PTCl4 molecule we have obtained this much axis and this much plane. In the very beginning we have seen in PTCl4 molecule there is present one principal axis having C4 rotation. There are present four C2 axes called as subsidiary axis. There are present four vertical planes parallel to principal axis, and there is present one horizontal plane which is perpendicular to principal axis. And now we have seen that there are present two sigma D's. That means there are present two dihedral planes in PTCl4 molecule. But if you will look at the diagram very well, this 2 sigma D we have passed from the same place from where we have passed the vertical mirror plane. Alright, this is 1 sigma V. From the same place, if you are passing a line, then it becomes C2 axis. From the same place, if you are passing a plane, then it becomes the vertical plane. Okay, don't get confused. From the same place, if a line is passed, it will become axis. From the same place, if a plane will be passed, that will become vertical plane. So like that, in PTCl4 till now we have seen 4 C2s, 1, 2, 3 and 4, and from the same places, from the exactly same places, we have got 4 vertical planes. Which one? 1, 2, 3, 4. This is earlier part I am talking about, not today's. I am just revising ki what we have seen till now in PTCL 4. Till now in PTCL 4 we have seen 4 C2s. 1, 2, 3, 4. From the I have shown it like the plane, but don't get confused. From in PTCL 4 we have got 4 we have got 4 subsidiary C2 axes. 1, 2, 3, 4. These are the 4 C2 axes. If you have forgotten, you can go back and can watch the previous videos. Now from the same places we have got 4 vertical sigma planes, that is sigma V. 1 first plane, second plane, third plane and fourth plane. Now you will see that ki I am saying this is vertical plane as well as this is what? Sigma D. So out of the total 4 sigma V's that we have seen before, out of that 4 vertical plane, any 2 vertical planes now will be called as dihedral planes. Why? Because according to the definition, they are bisecting 2 perpendicular C2 axes. So if you are choosing this axis, then these vertical planes will now be called as the dihedral plane. Or if you are choosing this C2 axis, then these vertical planes now be called as the dihedral mirror planes. So what correction we have to make here? Ki in PTCl4 molecule there are present 2 vertical planes and 2 dihedral planes. Why? Because the place from where we have passed vertical plane to the same plane we can call dihedral also, because these are bisecting 2 perpendicular C2 axes. I have tried to compile all the symmetry elements that we have got in PTCl4 in this diagram, just in order to avoid your confusion. See, by using red lines I have drawn all the C2 axes. We know ki line axis is indicated by a single line. So this is the first line, 1 C2, second line, second C2, third red line, third C2, fourth red line, fourth C2. If you have forgotten, I will revise again. How we can say that the C2 is passed from here? Because if you will pass the line or axis from here, then you will rotate the molecule in this and you are getting the same image, Cl, Cl, Pt, means we can say that the C2 axis can be passed from here. Similarly, along this line, you can rotate the molecule and you are getting the same image. As you are getting the same image means you can say that the rotation is possible. Now you can identify by what angle we are rotating it, by 180 degree. Hence it is called as C2. This is the third C2. Along this we are rotating the molecule and again we are getting the same image. Okay. And this is the fourth line, that is fourth C2. Again we are getting the same reflection, same molecule. Alright. So these are the 4 C2 axes I have drawn by using a red line, 4 C2 axes already. Okay. And already I have told you ki the places from where we can pass the C2, from the same place we get the plane also. So by using these green lines I have tried to draw on the planes. So this is the first plane, second plane, third plane and fourth plane. These are all these 4 planes, they are parallel to principal axis, hence they are called as vertical mirror plane. But among the 4 vertical mirror planes, any 2 planes they are bisecting 2 perpendicular C2 axes. So out of the 4 vertical planes, 2 will be called as sigma Ds and 2 will be called as sigma Vs. Remember, you can't call this and this as a sigma D at a time. Alright, if you are choosing sigma D one plane in this direction, then second sigma D must be drawn like this. Kiva, if you are choosing this as the sigma D, then another sigma D will be this. Okay, so out of the 4 vertical mirror planes, 2 will become sigma Ds which are perpendicular to each other and 2 will become the sigma Vs. And this is the C4 principal axis along which the molecule is rotated by 90 degree, and after complete 4 rotation the molecule will get its identical image. Hence it is called as the principal axis having highest fold of rotation. So this is C4, 1, 2, 3, 4 C2, 2 sigma Ds and 2 sigma Vs. I hope there is no more confusion for the elements that are present in CPTCl4. Simultaneously, I hope all the planes including dihedral, vertical and horizontal, all the planes are clear to you. Our next symmetry element is I, that is center of inversion. Before proceeding toward I, you have to practice more for getting the dihedral mirror plane. Which molecule I have drawn? C6H6, that is benzene. Similarly, as we have listed all the symmetry elements in PTCl4 till now, similarly you have to make a list of symmetry elements that are present in benzene also. For example, I will repeat, in PTCl4 how many symmetry elements we have written? There is 1 C4, there are 4 C2 axis, there are 2 sigma Vs, there are 2 sigma Ds and there is 1 sigma H in PTCl4. Such a list you have to prepare for benzene and with analogous to the PTCl4 molecule. Means if you will compare or if you will get, if this molecule is very much clear to you, then easily you can find out such a list for benzene also. I will just do the beginning. In PTCl4 we have got first principal axis, first element, that is one principal axis having fourfold rotation. Similarly, in benzene, in what way you will pass the principal axis? You can pass the rotational axis like this also. If you are passing the rotational axis like this, then in this way you can carry out the rotation. Alright, just rotate this axis, the molecule will get rotated like this. Okay, are you getting? Suppose it is the line and now I am rotating it by 180 degree. You will get the same image. Means what? The rotational axis can be passed from here. What is the angle of rotation? 180. So this line will be called as it is 180. So this line will be called as C2. But can you get any another rotational axis which is having highest fold than this C2? Yes, you can pass the principal axis passing through the center of this benzene. Benzene is also planar molecule just like PTCl4. Hence I told you ki if this list is very much clear to you, easily you can list out all the symmetry elements very soon in benzene also. So I will just give you the small clue or hint ki how to find out the list. First you will pass the principal axis like this. What will be the fold of rotation? If you are not able to find out the angle, ki by what angle we are rotating the molecule, and if you are unable to calculate the fold of rotation by using the formula this 2 pi upon theta, then no need to worry, you can simply apply your logic. Here we have C1, C2, C3, C4, C5, C6. This C means carbon atom. This C2 is what? It is rotational axis. Okay, and these are the carbon atoms, first, second, third, fourth, fifth, sixth. There are 6 carbon atoms in benzene. If you pass the rotational axis like this, and if you are rotating it in this clockwise direction, after first rotation what will happen? This C1 will come at the place of here, C2 will go here, C3, C4, C5 and C6. This diagram we will get. After second rotation, again this C1 will come here. After first rotation, the C1 has arrived here. After second rotation, it will go here. Third rotation, fourth rotation, fifth rotation and sixth rotation. Means how many times the molecule is being rotated to get exactly equivalent or exactly identical image? You are rotating it 6 times. So easily you can say that the principal axis that we are passing through benzene is having 6-fold rotation, or it is called as C6 axis. Alright. So I have started with your answer ki in PtCl4 molecule, in benzene molecule there is present one C6 principal axis. Similarly, now you have to find out there are how many C2s, there are how many sigma V's, there are how many sigma D's and how many sigma H. All the best.